Ready? All right, if I can ask everyone to come in and take a seat and we'll get started. My name's Fred Daring. I'm the moderator for this session, and I'm going to stand in front of the speaker and blow it up, so I won't do that. Welcome. This is our session on 3D design, or as we're now calling it, IDC, Integrated Design and Construction. Couple of housekeeping things. If you encourage everyone to take a seat, that's a new fire code thing. We're not supposed to be blocking the doorway. We do have a few more seats up front. We've got clipboards for the sign-in. As part of this year's conference, the certificates for continuing education will be emailed to you after the conference. So be sure to sign in and put down your email, and then they'll send you all your CEUs. Okay. Presenters, we've got Michelle Page from Central Construction, George Luke, Central Pre-Construction, Bob Peterson, Paul Wheeler are with the Technology Advancement Group, Division, TAG, whatever they call themselves, yeah. Chris Whipple, Region 1, Sam Grimshaw, Region 4. We're missing Andrew. If you're here, raise your hand. There he is. Okay, perfect, from Region 2. And like I said, I'm Fred Daring from Central as well. So with that, let's go ahead and get started. Is there something else I missed?
No, I think
Thanks, Fred. Welcome, everyone. It's good to see a lot of interest in this. We're really excited about it. For Carlos kind of kicking this off, we also feel like this is a huge part of the innovation, and we're really excited to get started with this. So what is intelligent design? And you heard Fred talk about this. We've kind of gone, I would say in the last week or two, to kind of this intelligent design and construction. So as UDOT, we've been doing 3D design for 20 years or something like that, and we're now getting to that point where instead of creating plan sets, we want to take models with surfaces and design details and information documents and pass that directly to the contractor so that we don't have the plan sheets and kind of that 3D to 2D to 3D. And you know what, before I go on, I'm going to really give you a quick overview. I'm going to talk for about 5 or 10 minutes and then kind of hand it over to these guys that have been doing all the work. And then at the end, we'll go through some questions and answers. So as an overview, we want to talk a little bit about what the benefits are. In design, you get benefits of things like clash detection, better collaboration with project teams. Our visualization tools are going to get much better, where we'll be able to have animations and photo matching and things of that nature. We're going to see embedded files and electronic reviews, where instead of having the plan sets, you have an electronic review. And also probably a GIS type, where at the beginning of a project you can see what it looks like now and what it's supposed to look like. Once we get to the end of design, we'll then have a handoff. And that handoff is going to be, the visualization is literally just giving the model to the contractor. And then the contractor can seamlessly put that into their software and start running their machines. And so this will be paperless advertising. The model is being the contract document and a seamless handoff. And then in construction, what we expect to see is basically a cloud-based, where again, we're going completely paperless and being able to have automated machine guidance, being able to have construction do their stuff. It's a little bit of everything. So our UDOT's IDC goals. Although it's listed as third, probably our number one goal is to advertise the model as the legal document. And right now, I think Sam's going to talk a little bit about that a little bit later, but there's a couple of projects in Region 4 where we're looking to do just that. SR20 is probably the one that's on the forefront right now. Like I just talked about, quick and easy transfer of information, where in essence, we're taking and doing the design and transferring it to construction, whether it's contractors or UDOT, and making it as easy as possible. Full electronic access. That's where everyone has access to information, whether you're in design or in construction. Yes? No, just kidding. And the ability to revise and resubmit as constructed data. What we're looking for, and it's something we're working on right now, is how do we get as-built and what does that mean? Is it the contractor who gives us an as-built in an open roads format, or is it the designer who sits through construction and does that as-built? Are we getting information from the contractor and putting it in? So it's not something we've fully figured out right now, but that's part of the as-built where, right now I think realistically we might get a scanned copy of something that's got scribble on it and call it an as-built. So this will move us into a new generation as well. So what technology exists today? For most DOTs and for UDOT, we use Bentley, and Open Roads is what we're using currently for design platform. We also have other entities outside of DOTs that use Autodesk. We have contractors who then take that information, and typically it's going to be Trimble or Topcon or AgTech or Leica or something like that. And then newer technologies are going to be ArcGIS and GIS technology. So we have what we would call pilot programs, and these are mostly programs that are designed in-house right now, although we have other 3D projects going outside. Right now in Region 1, we've got I-15, and I think that's a little bit about what Chris is going to talk about. In Region 2, we have SR-68 from, was it 123rd to Bangerter, and also the reconstruct on I-215. In Region 3, we have SR-68, which is Redwood Road, Saratoga Springs. I think that's construction 2017. It's been in here. It's right in there at some point. Or Andrew? Yep, 2017. And then Region 4 has 3. Probably the one that's right now at the forefront is SR-20, where the design's done in collaboration with contractor. The stars up there mean it's CMGC. Kind of the thought is that having the contractor on board early on will help us to figure out the problems that we may have in construction and try and get that back and forth done. SR-10 is going to be a little bit more complicated. SR-20 is an easy project in that we would never do at CMGC. It's basically road widening, right? Pretty simple project. SR-10 has a little more complexity. That one is going to be consultant designed. And then SR-34, St. George Boulevard. Is that in-house, Sim? SR-34 at St. George? Okay. And I think that's 2017 also, right? Close enough. Yeah. So those are the current projects that we're looking at. So with that, I'm going to hand this off to Paul, and Paul's going to talk a little bit about the survey effort we've been doing.
Okay, so with some of the 3D movement, we've been talking to contractors, consultants, design firms, and we kept getting the same thing coming back out to us. There's a problem with the survey standards. What they're finding is they're getting discrepancies. Some of the tolerances in there were not achievable. So there's a lot of problems that were occurring when they're trying to use automated machine guidance. So by looking at these, we decided to go ahead and change some things. So if you go back one slide real quick. And so what we did is we created a new survey manual, and it came out in May. And those that are looking for the manual, it's just on our website. It's you just type in survey and geomatics standards. That's going to be the easiest way to find it on the Google search. Or if you want to go through the breadcrumbs, it's under project development, central pre-construction, and then geomatics. And those that don't know what geomatics is, it's kind of the new name for surveying that's out there. So hence the survey and geomatics. That way it kind of encompasses all the different technologies that are out there. So that's kind of about this manual that's out here. So how it was formed. Instead of just UDOT putting the manual together, we actually got a committee because we wanted to make this right. The old manual is antiquated. It was old and outdated, so we decided to update it. But to form the committee, we got contractors, we got consultants, we got survey design firms, and we got a whole committee of us, also UDOT people as well, to try and create the best manual that we possibly could for this. And we met, it was actually last year, this exact time, in October, when we started doing the manual, and it took us till May, but it's out there now. And we want it to be kind of a live working document. So we don't want it to kind of be outdated again like the old one was. It was 1998, the last time the old one was done. And for the technology that was in it, it was good. But some of the tolerances weren't achievable. So it was calling out things that if you had to go and stand up in court and trying to defend those, it would be impossible because the survey equipment they were using, it frankly couldn't get those tolerances. And what that was creating was a bigger problem in that since those tolerances couldn't be achieved, nobody was checking it. And then those things were happening to where you get in construction and the contractor would find breaks and little problems with the control. And in the older days, that wasn't a problem because what would happen out there, you were using a string line. And with the string line, you just feather it out and make it fit, make it match. So it wasn't too big of a deal. But the problem we have now is if they're using automated machine guidance, with that, the machine does exactly what you tell it to do, which is a problem if your control is floating. So when I talk about control of control points, and what that is, the problem was when they're setting with GPS. Now, if you don't know what GPS, it's Global Positioning Systems. It's the satellites talking down to a piece of equipment we have down here, and it's sending a time signal. And it's very good for what it was built for. It was built by the military to actually blow things up, help them try and find that. But we're taking that technology and using it for survey. It works quite well, but the accuracies aren't very good. Horizontally, it's really good if you're using RTK, which is real-time kinematics. But when you're getting your vertical, it floats. So guess what? They're using automated machine guidance. They're punching this stuff into the machines. They're using the control that the topo is set off of. And instead of doing like the surface they wanted to do, the machine's doing exactly what they had. So the blade is moving along with what the control was doing and creating kind of a bad surface, and they weren't able to meet the tolerances of the pavement spec. And they're coming back and wondering why. And it all came down to the technology that was being used and the standards that we were having, and nobody was checking it like they should have. So that's kind of why this came to where it is. So let's see if you can go about one slide there. Okay, so the survey manual, what we did on it, there's a whole bunch of stuff in it, and I'm not going to bore you guys to death with everything that's in the survey manual. You guys can look at that on your own. It's right after lunch, and I'm pretty sure I'd put some people to sleep out there, so I'm not going to do that. But some of the things I do want to talk about is improved tolerances. So it's still fine to set control using GPS, but not for the vertical part. So that's what we changed. Before, I just had a tolerance of maybe 1/100th for the control. Well, that doesn't mean anything. 1/100th for what? So if you look in the new manual, it's actually equations for a distance-based system. So the closer you are, the tighter it's going to be, and the further out. It's an equation that actually will make more sense to surveyors to actually get the better quality. And with these improved tolerances and the control points, it also will address new technologies being used, like the AMG and also LiDAR. Okay, go ahead and switch on there. Okay, in that thing, there's some different charts now. So we're trying to make it a little bit easier for people to use it. And in those charts, it will show the positional accuracy, which is, again, your horizontal accuracy on there. And then it's also got spacing of how far your control points could be. Because if your control points aren't set close enough, the problem that's going to happen with your machines is it's not going to work very well because the spacing is too far, then your error is too great. So it also addresses some of your spacing there. And then also your typical applications for which accuracy you need to use for those. And then proportional accuracy, and some people have said, what is proportional accuracy? That's just your relative accuracy. So you have your absolute, which is where it's at on Earth, think of GIS systems, and then relative accuracy. And where this is important is for structures. See, part of it, we're creating a bridge control network that's actually going to tighten up the control for structures. But it's relative accuracy, not absolute. And they're kind of spelled out this way. And then you have your differential levels, which is going to help with those elevations so they don't float anymore. And then you have your base mapping tolerances. So this is the other part that we're hoping to address with the 3D movement, because the 3D design is all based upon the topo. Now, if the topo isn't dense enough or it's not done correctly, then the design's only as good as what that surface is below it. So it causes problems with the quantities. So we also address some base mapping problems too. So the tolerances for those base mapping. And then also in construction. And that's where, especially Clyde, we worked with WW Clyde, with Lance. And that was his biggest gripe, is he's having to go through our control, and he was actually having to go fix all the control and then before they construct it. But the problem was that everything was designed off of that, so it was causing some problems and a lot extra work that shouldn't have been done if we had some better standards. So hopefully this will fix that as we move forward in the future towards the 3D modeling. And that kind of goes too with it. So in the manual, get some feedback here. Move away from the speaker. Okay. All right. So we also want to address, use the right tool for the job, because there's all this new amazing technology that's coming out. We don't survey the same way that I used to survey anymore. We used a total station back in the day, you had chains. But now we've got LiDAR, There's drones out there that can just take pictures and give you a point cloud. There's many new technologies that are coming out, and we're hopefully going to address these in the manual, and they're amazing things. You don't have to do it the same way, and you can do things more fast, more efficient than what they've been. So in here, with the survey, we want to first focus on a meeting, a preliminary meeting, and say, okay, what is the intent of this design? Let's base our survey on what we're actually going to need. So let's have the design intent be up front first, and then let's determine what the accuracy requirements are of that. Do we really need it to be very tight, or is it just a concept level thing? But could this concept thing turn into a full design project later on? So look at the project and know what you're going to be doing. Then also safety concerns. So there's times if you need to do a topo and say like it's out on I-15 out here, there's no way to topo the lanes in there with a GPS very easily unless you shut down traffic. With new technologies, you can actually LiDAR the road, so it's a lot safer, or maybe you can't get into an area that you could LiDAR. So there's different safety concerns to look at. Also, what site constraints do you have? And then control needs. For if you have AMG, which is the automated machine guidance, are your control points going to be close enough? Then your budget, your schedule, and your availability of your staff. So by using all these things, we're hoping to move forward with this manual and get these standards where they need to be to help you guys towards the future, because we're moving towards this 3D movement, the innovative construction and design. And the only way to do that is to start with the beginning of what you're getting all your stuff and make sure it's going to work from the beginning up. And then also it addresses to our as-built some. We're still working on the as-built in Sioux, which we'll talk a little bit later, but we're hoping to address all these problems in the preliminary stuff in your survey and get it fixed. Okay, go ahead. Okay, now I'm going to go ahead and turn the time over to Bob and talk about some of the CAD stuff.
Right, a lot of the changes that we're doing at the CAD are due to going to open roads. Bentley has released a workspace as they implemented their new technology, and just trying to adopt what they're doing into the UDOT standards is the majority of this work that I've got outlined here. Temple Libraries, our library, if you look at our UDOT.ITL file, it's pretty lame. It's got very few things in it. Bentley has put out an ITL that has a lot of components, a lot of different things that will improve the design. So one of the things we want to do is get that switched over to our standards so that they're on the right levels, the right naming convention. We've issued a naming convention for our features, and hopefully you've seen that. I'm not sure how we made that public, or did we? Do you guys know about that? So we have a naming convention so that our features that are going out to the contractors will know what's what. And so we've got a convention out there. It just dawned on me, I'm not sure if we made that public. So we need to make that change. Feature creations, we need to make our features so that they're understandable, so that they can represent what we want designed. We're hoping to do a model as the biddable document. Well, we need to make sure the contractors can pick a feature and get information off of it. So these features need to have some intelligence behind them. They need to make sense. There's things like the cells that we're creating, the 3D cells. Struggles that I'm having with that is we can create a cell that is representative, but not exactly what it is. An example is a traffic signal. We've got all the different mast arms that we can put on. So right now we've got a cell that's the base, but then how do we attach another cell to that for the mast arm if it's a 45-foot, 50-foot, 55, and then the components that go on that signal pole. Is it a 5 light or a 3 light? Just how do we compose that 3D cell so that it's usable and that we don't have 50 million cells that are all the different configurations. So that's some of the things that we're struggling with that during that. We also, there are so many components that we don't have representatives of, and so one approach that we're doing is having the projects, as you need a 3D feature, you create it, send it back to us, and we'll incorporate it to save other people from having to create that. It's going to have a coordination hassle, How do we get all of these coming in? How do we get them distributed out? How do we get consistency in the cells? Are they all defined the same way? Are you using a mesh, or are you using a 3D solid, or are you using a feature solid? Different things about that. Quantity manager, we see a potential in that, in gathering our information and providing it for the contractors. We're struggling with that right now in its current functionality. We're having problems with the VDF. You're supposed to be able to create a VDF with the plan profile generator, use that VDF to cut your quantities so that they're based on sheets. Once we get into a 3D model, that won't matter, but in the meantime, to get the quantities on a per sheet basis, we're struggling with that. It wasn't functioning for us. Volume quantities, the way the quantity manager does the volumes is it takes an area and gives it a depth. We've decided in our technical committee that's not how we want to get our volumes. We want to get our volumes straight from open roads. That'll give us a true volume. But that's not incorporated into the quantity manager. So how do we get that information conveyed to the contractor of what our quantities are? We have a tool for, so if we can get the quantities built into the drawing, we can generate the quantities. We have a tool that Bentley's prepared for us that will extract the database into a spreadsheet, and then we can manipulate that spreadsheet to get the format we want for the quantities. iModel requirements. There are 3 different iModels that are created: an i.dgn, which would be read by MicroStation or any of the Bentley viewing applications; a .iModel, which is for the iPads, the mobile technologies; and an ICM, which is the coordination with Trimble. They're hoping to expand it beyond Trimble to get all the other companies. It's supposed to be an open format that you can just extract your surfaces, your alignments from it. We're struggling with that. ICM, we're currently in coordination between Bentley and Trimble to get those set up. We need to develop procedures. What toggles do you turn on and off? I always tell people with Bentley, if you're having a problem, there's a toggle somewhere that's messing you up. And so we need to define what toggles we want set as we create these iModels so that we give the right information to the contractors. SUDA design standards. SUDA just came out, I believe it was in July. SUDA is a subsurface utility design and analysis. It is the replacement for storm and sanitary for those who do hydraulic design. And it also gives us utility information. I'll be doing a presentation tomorrow morning on that, on what we've got and how to use it. One of the big things that it gives us is clash detection. So we're hoping with these 3D cells that we're creating to represent the features, I'm mostly concentrating right now on those that go into the ground. So I've got Jessica Andrews created a ramp meter signal pole. That one is a consolidated. There's only 3 options, so we've got 3 cells, but that one goes into the ground. We place that, and we can check it and see if it's in any conflict with any utilities, any storm drains, storm lines. So the clash detection is going to be helpful. We just place all these cells, place where they're supposed to be. The signs, I've got a lot of the sign bases in, and we can check and see if there's any clash detections on that. So that's an enhancement that SUDA is going to be giving us. Element templates replacing the XIN. Bentley's pushing us away from the XIN. We're still staying with the XIN because we still have a lot of people in the SS2 version. Once we break away from the SS2 version, element templates give us a little bit more functionality in definition of assigning materials, assigning the symbology. There's a lot of more capability in defining a feature with element templates than there are with the XIN. And so we're moving away from that. CAD-GIS, we're working on ways to simplify the movement of CAD data. Region 4 is taking a big jump on this and grabbing their designs and move it into the GIS system. So we're trying to develop some tools to make it possible to get that into the GIS so we can easily transfer our CAD data into GIS. Right now, that's for preliminary design. Who knows, that might be the way we convey our construction information. We just don't know yet of how we're going to be using GIS, but we want to be able to grab our DGM files and move the elements into the GIS system. The utility GIS data import to CAD, where Richard Mansur has a project where they're trying to develop and make a database of all the utilities in the state. We're working on getting that so it displays into the CAD system, so we can use those to test for clash detection. We can see where all of our utilities are and work with that. I think that's all I've gotten, so we'll turn the time to Fred, I think.
Thank you, Bob. So, you've heard a lot of things about what we're doing here. The reality is we've got an awful lot of balls in the air at this point in time, and unfortunately there are 3 or 4 or 5 different people who are juggling those balls, and they're not necessarily communicating with each other, coordinating with each other. And that's what we're trying to do here, is to get everyone working together towards that common goal. So some of the initiatives we're working on, like Bob was saying, GIS implementation. Richard Mansur's doing the whole utilities database deal. Construction's doing the MasterWorks implementation. The field book side of that is going to be implemented July 1st. They're doing the bid system is going to be through there. And the materials database is going to be through MasterWorks. And there are other things that they're looking to do as well in phase 2 of MasterWorks implementation. All of these things tie directly to the design. How do we get quantity information from a design into the field book so that the contractors can process those for payment, et cetera. Meanwhile, we got the 3rd floor working on asset management. Currently, they're going out and collecting LiDAR data to identify all the assets. One of our end goals in this whole process is that as projects are built and completed, and we've got that as-built data, that will automatically update the asset database. And eventually, we're hoping to eliminate the need to go out and collect this LiDAR, hopefully sooner than later, because it's very expensive to go out and collect that stuff every year. So that really leads to what it is we're trying to do here. We're trying to develop what we're calling the existing conditions database. A master database of every asset that UDOT owns that is updated real time as projects go. That's the end game here. And so we've got a lot of things to do to get there. All of this plus many, many more. That's really going to help us with our asset management, planning. They can now have an accurate idea of what's out there. The idea is to display all of this through GIS and make it a useful tool, make that knowledge available for everyone in the department. That's one of those things on George's very first slide. We're trying to make that information available to everyone in the department. Okay, so what's next? Region design update. So George alluded to it. We've got several projects going on live right now, trying to do 3D design. So why don't we start with Region 1? Chris?
All right. Good. Andrew
If you
needs.
kick the lights on back there, that'd be awesome.
Yeah, you don't need slides anymore. You can wake up. Okay.
Thank you.
Yeah, I'll just give you kind of an update. Georgia put up their, Georgia and Michelle had I-15 up there. We aren't doing much different with that one, just because we ran into some complications, which I think Andrew knows about. And anybody who's worked with open roads is kind of figuring out. But what we've started to do with some of our projects, Dave Adamson and PJ and a couple of our REs and some of our projects, we've looked at not so much putting everything into 3D right now, just because of some of the complications and getting it to the contractor. But we've looked at more along the lines of simplifying what we do on the design end so that we aren't replicating things when we hand them to the contractor, or they're not replicating them once they get them. I mean, the process, in as much as I understand it, we design things in 3D. We've done that for years. We pull all that out, we throw it onto sheets, we hand it to their surveyors. Well, we hand it to the contractor hands it to his surveyors, who types it all into his data collector, goes out, recreates everything. On some of the bigger projects, they actually have engineers there on staff, recreate everything, find out where we screwed everything up, and then they redo it. And it's kind of a silly process right now. But what we're trying to do is get more of a, in Region 1 anyway, where we strip off all the callouts. It's all electronic data that we give in like a CSV or a spreadsheet type format. That the surveyor can then just download straight into his data collector. And then we're giving minimal information on those plan sheets. We just show them where things are, simple callouts, kind of give them an idea where things are. And then from there, our quantity manager, what Bob had talked about, I mean, it's the same thing. It's been there for years. It's got all its little problems and quirks, and we're trying to get it so that all gets automated straight into summaries. And so we're still giving them summaries, so they can still go out there and find out how much is where and figure those things out. And then the surveyors are the ones that are going to be laying everything out rather than recreating it and trying to duplicate what we do. Yeah, I mean, because even now, you can get it good enough and you can give it to them, right? But it gives us more time to focus on making those designs, those 3D surfaces and those 3D features and elements what they need to be. And so that's kind of the direction we've been going. Not so much the 3D contract document yet, but more simplifying things and making it less error prone. And it's we're struggling through it, which is good because we got to see some of those shortfalls and George is having fun conversations with Bentley and telling them it's hard for them to understand what we really need, and I think they're slowly getting it. So yeah, we'll let Andrew take over.
Can wear two hats.
Yeah, I guess I'm kind of representing two regions a little bit here. Most of my experience has been with Region 2 recently, just being in Region 3 for the last 3-4 months. Region 2, I was lead designer on 215. That project was one of the first ones out of the gate to go, but Sam has greatly surpassed us on our development in 3D and that. But we were first out of the gate into the 3D, and our main goals with that was just trying to get the groundwork laid, trying to get the initial background developed so that it was easier in your design to place the 3D cells, to place, to go through the different features, to make sure that what we were trying to do in the OpenRoad software was there. So with the 215 project, the main thing we were looking at is to get the groundwork laid so that everything kind of went the way we wanted it to go, and to try out some of the things, introduce some of the functionality, such as the quantity manager, trying to get that data to push through and actually push through the iModel. That currently isn't happening. And that was one of the things we found. So we know what we can't do yet. And we found out a lot of those actually on 215, that there are a bunch of things that we are just wanting so greatly to be at the very next step, that we're trying to get that, to get it there. And we're getting there very slowly. I think it's the law and inertia, objects at rest. We've been doing the same thing.
I like the new quote today, longing for the future.
Yes, longing for the future. We're there. We're longing for it. We want to see it be there, but it is just so slow. We're just getting rolling, and I believe it's on the edge of taking off with the new stuff that's coming out. So with that, we implemented the clash detection on that job. We did the quantity manager on that job, where we found the issues with the VDFs. Multiple alignments it doesn't like very well. So when we got into the ramp alignments and stuff like that on this dual alignments on main line, really ran into issues there. But so that one got kicked out, and then clash detection's moving forward. We're doing more there. We're developing more cells for the SUDA, and getting that groundwork laid. So that's kind of where we've been on 215, is just testing out some stuff here and there. And then in Region 3, we're going to be kicking off with the Redwood Road down south, headed from Saratoga Springs south, down through there. That one's going to kind of pick up. I'd like to see that pick up where Sam leaves off and where Chris leaves off on those regions, because that one's a little bit further behind. We got construction in 2017, so just keep learning, developing that technical committee, developing that baseline is where we're at right now, and just building that up. So that's kind of the update on where Region 2, 3, where we're at. So I'll give it to Sam. Sam's well more advanced in the deliverables and the construction stuff. He's really been doing a lot of work there.
Thank you. Not really. We have 3 active projects that we're looking at doing 3D as the contract deliverable. SR10, SR20, my project, and then SR68. Is that correct, Monty? 34. On my project, what we have learned is that, you know, when you pioneer a road, you find a lot of things that you didn't expect. On my project, the hope was that we could take a 3D model that I spend 4 months on building, looking at, making nice, and not spend 4 more months on making 2D plan sets that are black and gray lines stacked on top of each other, kind of dumbing down the information. We would like to pass that rich, robust 3D model onto the contractor and to our REs so they can use it for contract administration, measurement, payment, etc. What we found is that the ICM, it's cleaner, I think, than the previous way of transferring data. When we make an ICM from our model, we found that the quality of that model has to be a lot better. We've got a contractor on board, WW Clyde, that has helped us. Instead of trying to guess what the contractor needs, we've come out and, believe it or not, we just asked them, what do you need? What surfaces do you want? We haven't had as much success with the ICM as we'd like. In fact, it's, I don't know if I've got some, oh yeah, we do. So here is the 3D model. I get it solving correctly. It looks nice and pretty. But when you import it into Trimble Business Center, it's creating different features and surfaces that I didn't know I had created. So basically, right now, the translation process is really, that's the bottleneck. The current challenge is getting what we produce as designers in its clean state to the contractor. So they're not reproducing, rebuilding, adding in, you know, additional tasks that can lead to, you know, anytime you have additional processes, you can add in the grade or enlarge in the margin of error. So hopefully in the near future, we can get to where what we produce is taken by the contractor, used for construction. The RE can take it. They can manipulate these 3D objects, pipes, riprap, whatever, document it on an iPad or a smart device, and not worry so much about paper and scribbling on paper. Basically just utilizing the data that pre-construction produces, which is a huge amount. So our success so far is that we are going to produce a 3D model for construction and a plan set, just so the contractor and the RE have something to document right now. But hopefully in the future we can get that technology that allows the contractor and the RE to utilize that 3D model for documentation, for construction, etc. But yeah, the real bottleneck right now is getting the data to cleanly translate from what we build to what they build. So that's what we found.
I'll take 2 seconds and then pass this mic off. I would challenge all of you to remember this moment because we are on the cusp of that greatness of going to 3D modeling. All of these challenges to push that envelope, to test the limit, to hit what we're calling those roadblocks in intelligence, to bust through that barrier. And I know that we'll have those moments like Carlos spoke to this morning when we say, where were you? What job do you remember the first time we actually went from not having a 2D plan set, that we were doing save views, that we were accessing the data from a cloud, that we were current on the version that we were using, that we actually could see the data transfer from design to contractor to survey to having that data come back into our systems to having it geographically represented. Those moments are about to happen. You know, I don't know how many of you guys have a Vice. One of mine is The Voice, and just the other night, Gwen Stefani was talking about it's happening. It's happening right now. This moment is here. And that's how 3D modeling feels to us in the middle of it right now, is there are days we kind of turn the computer on and off again and reboot because things are backlogged and jamming up in it. And we're like, oh, I can't believe this new software is doing this. And then there's other times we're like, oh, look at what we just got. You know, how often have we been able to have a model that you can touch and feel, that you can see the existing surface, you can see the alignment, you can see those visual things that you've talked about in school or classes or in the field with a mentor, that they had it visualized in their mind, but they couldn't translate it into words. You now have that visualization tool. So we're so close. There's still roadblocks, but I'll pass this off to Fred and let him hit the last one.
Well, I think you did a good job with that. So the question is, what are we going to do now? What can we do today? Not we, what can you do today? How are you going to help us to achieve this vision that we have? And this really is going to take all of us working together and communicating and sharing our experiences and learning from each other, trying to get ahead and move this whole process forward. Okay, so it's all about that last word on this slide, collaboration, right? Hopefully we've done a good job of sharing what our vision is, where we want to go, and sharing the steps that we're taking so far. And I know a lot of you are doing things that we don't even know about. And if you could share those with us, that'd be wonderful. Tell us what you're doing that's working for you, or things you've tried that aren't working for you, so that we don't try them again. Especially our consultant partners here. I'm sure around your company you're doing other things that are working for your company, and we'd like to know about that. What else have we got? That's it. So, those are our goals. We still have, I think, a few minutes, so why don't we open it up to any questions? We got 15 minutes, so let's open it up to a lot of questions. Anything.
All right, go ahead.
So as we're moving to delivering 3D models, one thing we're really good at with 2D plan sets, there's a good old checkprint stamp where we can go through and quality control our deliverables.
Right.
What is your vision or goal of how we QC a 3D model?
So, okay, I don't know if everyone heard the question, but I think that the summary is, how are we going to QC models? Is that fair to say? So, it's a good question. I don't think we have the answer right now exactly, but I think the majority of the time right now is creating plan sets, right? Probably 60 or 70% of the time in pre-construction is getting your sheets ready. So that's going to leave a lot of time that we otherwise would be doing plan sets. And I think what we're looking at is that will be how we're going to use that time, is doing the QC. Right now, there's not a roadmap for that of exactly what the QC will be, but I'm expecting, just like any other electronic type device, there will be something that's either layered or allows you to put your signature on it, or something that says you've gone through and checked whether it's calculations or methods or software or whatever it would be, and that's how it would be done. I don't know that we really have that answer quite yet, though.
Hey, George, we had Chris the mic. He's got an idea.
Say that again?
Or I mean the mic to Chris.
Yep.
Flip-flopped it there. Sit down.
It's good, Dave. No, it's similar to the process we use now. Like when you create a model, you have to have somebody else that's technically competent to do the same thing, that can look at it and say, yeah, you missed this, or that's wrong. The nice thing about the models is you can step through it and you can see a lot more of the actual errors. And we'll be spending more time doing like the QC type stuff, where you're actually looking at how those models work. Some of the ones that we've been doing, you know, we hand it off to another designer, and he starts going through, and he's looking at your features, he's looking at your templates, he's looking at your corridors, and he's making sure everything is correct. But the nice thing is you can see that surface. You rotate through it, you can kind of drive it, you can check things out, and you can see the errors. You know, if there's anything wrong, you can see it. And again, it's going back to the templates where you're looking at like side slopes and clear zone and things like that, because all that information's in there. They're just verifying it a lot more. Yeah, you know, it's a lot more technical ability, or, you know, so you have to have somebody else that knows what they're doing in there. And I know it's tough to like get in somebody else's model and figure out what the heck they did. But that's kind of the process. And like you say, I mean, we do that now where we say, yes, I checked this model. I checked this. I mean, that's really all it's going to be. And it's not going to be, well, that's 11-point Arial font and it's bold instead of italicized, you know, so we can put more of that effort into the real design.
All right. Go ahead.
My question is for Bob. How much of our problems is actually Bentley and non-open roads, and how much of it is just us actually not able to get further? And then in addition to that, is Bentley working with us to change the software?
Yeah, for those of you that aren't affiliated with the department, Bentley has their product managers. Our design crews have contact information. Derek Gray, Kevin Jackson, Kevin McDonald. We have direct communication with them. Whenever we have a problem, we send it to them. Our latest problem is some corridors have been disappearing out of the file, and they've been looking at it. They can't see why that's happening. But Bentley is very interested in helping us getting that done. We are finding some of the problems. We had Region 4 had a problem where you zoomed in on a corridor, you get in a certain point and it just locks up. You have to reboot your machine, and we found that was a line resource file that we have. And so there's part of it is our workspace, part of it is the product just isn't functioning correctly, where we're having problems. I think each build, I hope it seems like each build, they solve some problems and introduce new ones that we're finding. But I think we're moving forward. A lot of it is our workspace. I found a lot, if you don't have the correct U.Civil XIN file in your project and you're trying to use these advanced features that we've developed, that is causing crashing. And so make sure that you have the latest XIN file that I've got levels created or features created, that the program isn't trying to find them through the XIN and wasting that time and not being able to resolve it. A lot of that. So did that answer your question about where we're at with that? So I think it's a combination of both us and UDOT, our workspace that we've got set up, and a lot of the SUDA stuff, the problems we were having, we used to carry a global origin in our seed files. We have to get rid of that global origin. A lot of different things like that the product's crashing on.
Great question. You know, like Bob said, it's a little combination of the two, but we hear from other entities that they have crashing problems too. I think one thing we found that solves it a little bit is rebooting. You know, instead of starting it over, turning the machine off and on has seemingly helped quite a bit.
Seems to be a memory buildup.
Yeah, it's almost like a caching or something. I think it was over here.
My question was just similar to Brandon, just seeing the responsiveness of Bentley and seeing if, you know, as we give feedback, whether the list gets longer or whether they're taking those items off and addressing those items.
So from a diplomatic standpoint, it's never fast enough for me. But, you know, they listen to what we have to say and they work on it. And, you know, frankly, it's programmers that are sitting there trying to figure it out. So they're in the background doing what they can do, and we're sitting here wanting it to be faster. So it's kind of a combination of the two. But, yeah, we always want it to be fixed in the next 10 minutes. So,
George,
yes.
if I may, I think some of this is a combination between the new software we bid off and the vision and the dream of where we want to go. And so we have the new software issues that we're keeping track of, and Bob's trying to write the standards and help get guidance around how to implement the new software. We're also heavily involved in their R&D side. So now we're talking about development efforts that we have to be very careful with state procurement laws of what we're influencing, what product we're getting. And right now, our contract is broad enough with Bentley. We're okay where we're sitting. So we're on the front row of that input. We also have the highest level of leadership supporting and involved in those discussions that on occasion they're a little slow to respond to, I'm going to say, a Fred, George, Bob level, that it's a Lisa, Randy, Carlos, Shane level. Very quickly happening at that. So those things that could have the pressure and get things rolling out fast are in place. It is never fast enough, but I at least wanted to share that we are on the R&D side. It's not just the out of the box that we currently have installed on our workstations.
Let me add to that really quick. One thing is, you heard Carlos today talking about UDOT being at the forefront. When we hear other DOTs, they're not moving ahead this fast. And so, you see Bentley responding, and we may not think it's fast enough, but they're responding to the ones that are using it kind of at the full force. So they have to decide where to put their resources also. I saw someone over, go ahead.
I've been working on it, on some UDOT projects, mostly projects with just our company standards. What I found was, I just basically, the only time I use XIN files for existing surveying is in past. And I found for anything was designed, as soon as you take the XIN out, it solves the magnitude of the problem. How long until UDOT does away with XIN for design?
It's on, yeah, I have to allocate 5% of my time here, 5%. I don't know. I really don't know. It would be a major effort to get that. Again, because of our SS2 users, I need to make sure that they still have the functionality. So if we ever converted the SS2 up to open roads, we wouldn't lose anything. It's completely different, but it's possible. Yeah.
My question is, get rid of, because that's the biggest thing I found as I've been working with it is the XIN file is causing the majority of my headaches.
Yeah. Yeah, the XIN, I don't know if any of you have looked at an XIN. It's a ASCII file. It's an XML file. But you get it's nicely formatted, and you get halfway through our XIN, and then it's just garbled. So I think we're building up waste in our XIN files, and I agree. We need to move off that XIN. That's why it's on our radar, but I'm just not sure how fast we can get moving on that. If any consultants would like to take our XIN and move it to element templates, I'd love it. Or Chris, I know he's just waiting he's got some downtime. Yeah, it's resources right now that's the holdup on that. And yes, we do recognize that there'd be a great improvement if we did move that way.
If we could figure out how to make 10 Bobs, we would do that in a heartbeat.
Yeah, and you know what? Quick story. We went to Iowa. I think they had 8 people in their group that were doing it. We look at Florida DOTs. They have 16 people doing it. We've got Bob. I mean, he's worth about 10 of those 16, but still, we need some more. What other questions? Yep.
You guys looked at focusing more on a deliverable that's more widely used, like an XML or DXF or something like that, maybe focus less on the methods to get to that point?
So it's a really good question, and XML was one that we originally had looked at. We have a document out that has deliverables. I think XML is one of those on that, right? There's also ALGs, DGNs. I think there's a DC deliverable on that one.
Yeah, we can.
It's a little bit of everything, and that was kind of our first effort, was to say, all right, let's give files to contractors for information only, and then go back and see what worked well and what didn't. And so that's what we did in 2014, and we had probably 10 or 15 projects where we went back, interviewed the project teams, the contractors, and found out what were the issues? And that's kind of what led to what Paul did, was they all said, look, the control points are a huge issue. There's not enough accuracy in them, and so it's still useful for them to take a land XML file or something like that, but it's not as good as having the survey be accurate up front. And so we've kind of moved in the direction of, I don't know that we're opposed to doing XML, but what we'd really be able to do is kind of what Sam's been working on, is give them an ICM, which is just handing the model off and it goes directly into Trimble. And then they've built their model and they can put it in their machines and then getting it back too. And that becomes a whole nother conversation, which we want to have happen, but where does it come from? Does it come from Trimble? Is there a land XML? Is there something else? It's hard to say. But to answer your question, that's where we started, and it's not that we wouldn't use that. It's just, I think we're moving in a direction where instead of taking all of the formatting off it and passing it, we want to pass it with the information so that it doesn't have to be recreated. Any other questions?
I'd go back to that call for action a little bit and maybe summarize with the goal that we left at the end. If you saw the years up there for 2015, 16, and 17, things you can do today, things that are very easy to do, is the handoff. Make sure that electronic data is available to the awarded contractor. If you can advertise the electronic data, that's even better. I-215, something very unique and special they did during advertisement is they reached out through a questionnaire and said, here are the high-risk elements to us as a department. We've got concerns about this certain application. Please give me some feedback. Are the plans and specs sufficient? Is the data file sufficient? Do you have some of the same concerns? We got a pretty good response back from that. It gave us a flavor for where our concerns were validated and where we maybe didn't need to worry about them. So anything new as far as sharing data and getting information will continue to move this effort forward. Beyond that, for us, the focus is intelligence. If you think of this as a Google Earth view, I want to be able to walk through, touch, and zoom and connect to any data that I know exists. And really, that's the embedded files, that's the contract documents, that's the specs, DGNs, ALGs, all of that. That's why we switched from this being more than just the model itself or models. Those are some of the challenges we maybe didn't talk in detail, that in some instances, if you do a single iModel, it is too large to export and import back in. So now we're learning what are those boundaries that we should define a iModel in, maybe a structures iModel, and is that in LEAP? What system is that in? All of that stuff is happening in those technical areas right now that they're defining their standards, and I'd ask you to get involved with your industry side of it. Your ACEC, we're at the table with them monthly. AGC, we're at the table with them monthly. If you're a consultant with the department, come forward with ideas. If you want to be part of a workshop or a committee, come to Georgia I. We can't do this alone. We're definitely, I'm going to say, arms reached out saying, let us be a sponge. We aren't the smartest and brightest. I'll be the first to say that it is the youth. It is this younger generation. It is a lot of these folks coming right out of school that know how applications interface, how systems integrate. That technology is what we need to get our fingertips around, that if it's not what we've traditionally used, we need to know now so we can choose a tool and go forward. That's where we're stuck right now.
All right, I think we're about out of time. Any other last questions? Yeah.
Is it far-fetched to say that to have our designers treat the Trimble?
You know what? I don't know that it's far-fetched. In fact, that's kind of one of the conversations we've had is, forever we've created plan sheets, and there hasn't been that transfer of files to contractors. Now, all of a sudden, that's becoming what the desire is. That's what we want to do. It may be Trimble, it may be Autodesk, it may be Bentley, it might be ArcGIS, it might be something that has been yet to be created where you have that transfer of data seamlessly. So, I don't know. But right now, we and DOTs use Bentley. And then when you step outside the DOT doors, no one uses Bentley. So it makes it more challenging to do that. So to answer your question, I don't know, but it's a possibility. I don't know that anyone would say, no, we're never going to use a different platform. Any other questions? All right, thank you very much. I muted it too. Did you mute it?